Hello everyone, my name is Kiran Devihosu and today we will discuss this interesting machine learning based project called Pit Stop Analytics. So what is Formula One racing? It's a high adrenaline sport where risks are high and teams and owners are constantly strategizing for success. With that in mind, let's explore how machine learning can help predict championship outcomes. So, coming to the introduction, for fans, F1 is a thrilling ride full of emotions. People are deeply loyal to their favorite teams, often wearing their colors with pride. The ups and downs of the drivers and teams really connect with fans, creating a passionate community that stretches worldwide. Whether you're cheering for the underdog team or the current champion team, F1 gives you a sense of belonging and a shared experience that is truly special. Whether you are a long-time F1 fan or just getting into the sport, there's always something new to discover and experience. Here in this project, we are going to discuss about predicting future driver constructor championship using machine learning models such as Navi-based, decision trees, SVM, and neural networks, making it a captivating subject not just for the racing enthusiasts, but for anyone curious about the limits of human ability and technology. Coming to the goals of the project, the primary goal is to predict the championship results over the several seasons and analyze the key factors that led to the success. This includes examining how drivers and teams coordinate and communicate to enhance performance, choosing the best pit stop strategies and tires to gain a competitive edge over the other teams, and using circuit and weather conditions to select favorable starting grid positions. Fastest laps and completed laps are considered to accurately predict future race outcomes. Additionally, smart budgeting for car designs plays a crucial role in ensuring drivers perform at their best. So let's talk about the data and its source. For this project, the Ergast F1 API was used, which is a valuable resource for historical Formula One racing data. The API provides detailed information across many seasons, including lap times, driver standings, race results, and circuit details. By extracting data from different API endpoints, key features like starting grid positions, pit stop times, fastest lap, and the number of laps completed were gathered. It also includes standings for drivers and teams, which are important for understanding the team performance and strategies. Below, you can see the two examples of API endpoints. The race results API, which is utilized to access the detailed data on the specific race, like finishing positions, laps completed, and points earned. And the second API, that is the driver information API, it is utilized to obtain data on current drivers, their statistics, and their rankings. With this data, important patterns can be uncovered to build accurate predictive models and that help teams to improve their race strategies, enhance driver coordination, and build cars that perform optimally. Yeah, let's look at the data description. On the left hand side, you can see the raw data that was extracted from the Ergast F1 API. This data includes details about the races, like the drivers, their positions, lap times, team names, and track information. On the right hand side is the clean data. The data cleaning process involves several steps like removing any empty or duplicate entries, renaming columns to make them easier to understand, combining multiple data into one comprehensive final data set. After cleaning, the data is ready for further analysis, which can be shown in the next slide. Coming to the exploratory data analysis, on the left, we can see the heat map, which shows how many times each team reached to the podium in each season. Green colors indicates many podium finishes, while yellow and red colors show fewer or none. Ferrari, Red Bull, and Mercedes frequently appear in bright green, meaning they have consistently finished in the top three across many seasons. Other teams like Jogger and Toro Rosso have more red and yellow colors, showing fewer podium finishes. The heat maps make it easy to see which teams have been the strongest over time and which ones have struggled. On the right hand side, we can see the line chart which shows the total points scored by Ferrari, Red Bull, and Mercedes from season 2000 to 2023. The lines represent how these teams have performed, with peaks indicating strong seasons and dips showing less successful seasons. Ferrari was strong in the early 2000s and then leveled off. Red Bull gained strength around 2010 and stayed consistent till date. Mercedes became very strong in the mid 2010s and remained dominant. This graph clearly shows how these top teams have competed over the years and the changes in their success. So let's talk about the results and findings from the analysis of Formula One data using different machine learning techniques. So the cluster analysis with K-means and hierarchical clustering shows group drivers and teams into different performance categories like top performance, rivals, midfield battlers, and lower division competitors. This grouping helps highlight performance patterns and strategic difference among teams. PCA was used to reduce the complexity of the data while identifying the key factors for success. This method shows that qualifying performance, pit stop efficiency, and grid positions are the most important factors in influencing the race outcomes. Supervised learning algorithm further refine these predictions. The Naive-based model achieved an impressive 89.57% of accuracy in predicting whether a driver would become a champion or not. By looking at the historical data like grid positions, points, and laps completed, this model provided insight into what contributes to winning. The decision tree model excelled with a 99.13 accuracy in distinguishing champions based on factors like total points, wins, and podium finishes. Its visual paths made it easier to understand the key elements that influence the championships. The SVM model, using a linear kernel with C value of 0.1, achieved a solid 96.52 accuracy in identifying future championship effectively. Overall, these models provide valuable insights into predicting championship outcomes. They offer useful information for teams to refine strategies, improve driver coordination, and optimize pit stops. The K-means clustering plot on the left-hand side shows the groups, teams, and the drivers into five performance categories, each represented by a different color. Every point corresponds to a team's or driver performance based on qualifying results, race finishes, and points. The cluster reveals patterns that distinguish different groups, such as top performance, rivals, and midfield battlers. On the right-hand side, the PCA scatter plots reduces the data into two main components or principal components. Each color indicates a cluster identified through the k-means process. The visualization clearly separates the five performance groups, making it easy to identify competitive differences among the teams. It provides strategic insights into how teams compare and where they stand against their competitors. In this slide, we are going to discuss about the efficiency of each model through the confusion matrix. The Navy-based confusion matrix on the top left reveals that the model correctly identified 97 non-champions but mistakenly labeled 12 as champions. However, it was successfully identified all six actual champions with no errors. Despite some false predictions, it provided valuable insights into distinguishing between different drivers. The decision tree matrix on the top right demonstrates near perfect performance. The model correctly predicted all 109 non-champions and the five actual champions without a single mistake. This impressive accuracy makes the decision tree a reliable predictor. The SVM matrix on the bottom left indicates that the linear SVM model with the C value of 0.1 correctly classified 108 out of 109 non-champions, but it misclassified one as a champion. For actual champions, it accurately identified one out of four, highlighting some difficulty in classification. The neural networks matrix on the bottom right shows that the model accurately predicted all 109 non-champions. However, for the six actual champions, it correctly classified only two while mislabeling four as non-champions. Overall, the decision tree model proved to be the most efficient model for this project, achieving the highest accuracy in predicting champions and non-champions. The neural networks model follows closely as the second best performer, consistency classifying champions and non-champions with high accuracy. So, coming to the conclusion, success in Formula One racing depends on consistent performance. Drivers need good starting positions, frequent podium finishes, and well planned pit stop strategies to secure victories. The analysis showed that studying past race helps teams understand which factors matter the most, allowing them to refine their qualifying strategies and allocate the resource more effectively. The project revealed that historical data is crucial for guiding teams and strategies. By understanding which key factors contribute to success, teams can improve their tactics, make smarter qualifying efforts, and budget their resources better. Formula One is a fast paced sport where performance can change rapidly due to new technology, shifting team strategies, or changing rules. Predictive models must constantly improve and adjust to new data, making ongoing analysis essential for staying competitive. Ultimately, the most successful team are those that can quickly recognize trends and adapt to new challenges and make informed decisions during the race. By using accurate data analysis, teams can enhance their tactics, improve teamwork and communication, and design cars that deliver outstanding performance. This approach will help them secure more victories and championship titles. Thank you.